Okay, the next thing we're going to talk about is transforming data. So, if we look at a set of data and we are able to plot the data on some sort of axes, and so this is just an imaginary data set that was created. X is along the horizontal axis and Y is along a vertical axis, and X and Y here don't have any real context. But looking at the data, we see that the data has this kind of upward trend in one variable, so meaning that one variable is increasing at a rate that's faster than the rate at which the other variable is changing, and so that this is okay, but we're assuming that with this we get some sort of non-constant rate at which the data is, or that at least one variable is changing, and one way that we can counteract that is to apply a transformation to one or both set of axes in order to make the data look linear. And so this is we're going to choose a logarithmic transformation. And so really what this is saying is just kind of squishing down the axes so that we can do some better data analysis. Because if we can get some sort of line going through the data, and the trend line for this set of data might look something like that. And if we can get it to a line, lines are well studied, and we can determine a very nice relationship between the two variables that we're studying if we can get some sort of line in there. And so our goal is that if we apply a transformation, so here this is just if we took a log y, or if we logged the y-axis, we would get something that would look like this. And the trend line here would be something more like this. And so it would better describe the data, and we could have some better inferences based on this. Now, one example that was studied in statistics, we have a scatter plot made for x and y here. You can see all the data points are plotted, and then we have the trend line inserted, and here's the equation of that trend line and the r squared value. Remember the r squared value, we call that the coefficient of determination. And the higher that it, or the if it's above, say, zero point 0.5 or 1, there's a very strong correlation between the two variables. If it's less than zero point 0.5, there's very weak correlation, or there's a weak relationship. And so our goal is to take the set of data and see if we can apply this sort of transformation idea to it to increase the r squared value to above zero point 0.5, or at least close to, so we can have some better idea of what is happening to the data. So what I want to do is, and we have a couple activities that will go through this in more detail, but I'm going to apply a logarithmic transformation on both of those, and the command to do so in Excel, I think this is Excel 2007, is equals log 10, this one, and then you can hit tab to insert the entire command automatically for you. And now we want to cell reference the x value, okay, and then we can hit enter. Do the same with the y, and we're going to try them both first, and then we may need to do some modification after. Log 10, and then click on the y value, hit enter, okay. Click and drag over both of those, and then down in the lower right side here, there's a little black box. You're going to drag that down, and what this does is it copies the formula into all the cells that I'm dragging down to. And so I want to drag, I think this is the end, and so it automatically computes log 10 for all those values. Now if I want to obtain a graph of those, I highlight the data including the labels, so it'll insert the labels for me. Go to the Insert tab in the ribbon, go to Scatter under the Charts section, and then I'm just going to plot the points, so do a scatter with only markers. And there's my new my transformed data. Okay, so now I'm going to insert a trend line, go to Layout, and then Trend Line, and we're going to insert a linear trend line. Okay, so it's inserted it, but I don't know the equation and I don't know the r squared value, so I select the trend line, double click on that, and then down towards the bottom there's display equation and display r squared value. Okay, and let's see, I can't see that, so I'm going to move that over. And now the r squared value, it's higher, but it's still not above 0.5 like we wanted. So unfortunately at this point we don't have enough tools to go further, but this is just to demonstrate how you go through that transformation process. And so here we don't have enough. We would have to conclude that there is only a weak correlation between the two sets of variables. And that's in short how you do a logarithm, or how you do transformations with data.